All right, so here now we're solving rational equations. So this is an equation where you have two rational expressions, one on each side, or you may have three, two on one side, one on the other. You guys should remember this process. Do you guys remember this process called cross multiply? It only works when there's an equation, sorry, when there's an equal sign between the two fractions. It only works. So very, very important. So yeah, I don't want you guys getting this stuff confused. Only works when there is exactly one rational expression on each side of the equation. Okay, I can't emphasize that anymore. Exactly one rational expression on each side and nothing else. So there can't be a whole number being added or subtracted to it or whatever. It has, that's all you got. There's just one rational expression on each side. And then at that point, yeah, cross multiply is pretty easy. And the way it looks is you kind of lasso these two and you lasso these two and you just multiply them together. That's all. So let me clear and do it for you guys. So these will be multiplied and these will be multiplied. That's why it's called cross multiply. So 3 times -2 equals x times -x plus 1. Instantly, you break up the fraction. Fractions are, I think, usually cause a lot of stress and anxiety, right? Let's get rid of that stress and anxiety and just get rid of the fractions right away. Right, yeah, good. Oh, sure, yeah, I'll help you out. Don't worry about it. Yeah, you're good. If I have an X1, hold on. You know, the trees are already, I already killed the trees anyway. So. Okay. Thank you. So anyway, once you cross multiply, just work it out. I know you guys can work it out. I'm not worried about that. But you just have to remember to cross multiply. And I'd probably move everything to the left side just to get rid of the negatives for the leading term. And then you can factor. So you see, when you guys ask, like, am I testing on first semester stuff? And I sometimes can't answer that question. Because yes, I am testing on first semester stuff, factoring. But is it specific to the first semester? No, because you guys have been factoring for a long time. So yes, there's skills, but anything that was unique to the first semester, of course, I'm not testing you on the final. Yeah, good. Isn't it? Hmm? Did I make a mistake? Hold on. Oh, you know what? Good job, Hugo. Hugo caught my first error today. Thank you so much. Okay, I made a mistake, guys. I didn't distribute correctly. Human error. But you know what? I was going to check my work anyway, but think. So x times -x is -x. So I did that right. I did this wrong. Times 1, x times 1 is x, but I put -x accidentally. Oh. Yeah. So thank you, Hugo, for catching that. So now I should be able to factor correctly. X minus 3 times x plus 2. X equals 3 or -2. Now, if I check my work, just to make sure I did it right, because you should always do that. If I plug in 3, I should get 3 over -2 on the other side. I do get 3 over -2. But see, I was going to actually have -3, and I've had a different answer if I did that. If I plug in -3, I would have 3/4 and 3/2. So that would have been a problem. And then also, if I plug in -2, just to be sure, I have 3 over 3. I have -2 over -2. Those are the same also. So always check your work. And also check for extraneous solutions. What that means, for extraneous solutions, make sure you make a note of this, please. Denominator can't be 0 after plugging in the solution for x. Okay? The denominator cannot be 0, because if it is, that's a problem, right? Can't divide by 0. All right. Now, for example 6, you can't cross multiply yet. Because do you have exactly one fraction on each side? No, right? So what you could do is combine the two fractions on the left side and then cross multiply afterwards. If you do that, 5 over x minus 7 over 4. What's the LCD for those two fractions, guys? Good. So you have x and x, 4 and 4, easy peasy, right? So you're building upon the previous topic, right? So you should get 20 minus 7x over 4x, right? Yeah, what's up? I'm gonna get there. I'm gonna get there, guys. Don't worry. Yes. You guys are a step ahead of me. So you have 20 minus 7x over 4x. And then you can cross multiply, right? Which you get 20x. By the way I'm doing this is not the most efficient way. Just to tell you right now, there is a better way, which I agree with what you guys just said. But in case if you're stuck, this always works out. Combine the two fractions, cross multiply afterwards, right? Because now I'm cross multiplying, right? I'm multiplying this with this and this with this. If I work things out, I should get 0 equals 7x squared plus 16x. Is that right? Yeah?
No, it's 6. I got 16 over 96.
Yeah, no, you're right. Yeah, you're right. So then you can factor on x. I'm not doing the most efficient way. So x is 0, or you said negative 16 over 7, right?
16 over 9.
Same thing, yeah. So, but however, 0 is extraneous because you can't divide by 0. So the answer is just that. Okay. Yeah, I did quite a bit of work for that one when I don't think I really needed to. I could have been way more efficient with this problem. But that does give me the answer. Let me show you a more efficient process. And I'm going to use this more efficient way for the rest of the notes. So yeah, I heard some people say, let's combine these two fractions, right? Which I would agree. That would be a wise move. So you have 9 over x minus 5 over x. Is that what you guys are saying? Yeah, totally agree. So 4 over x, see how much cleaner that is? Yeah, then you get negative 7x equals 16. See, I did some way fewer steps, right? There you go. So if you see an opportunity to combine fractions that already have the same denominator, please do so, because that's going to make your life much easier. It's fewer steps, less likely to make a mistake. The previous way was really insane. I wouldn't recommend that. But you could do it that way, combine the two fractions left side and using the LCD, you could do that. But I think this is way better. I agree. There's yet another way to do this too. So these two fractions, I'm saying, so you can combine them really easily. So if you see an opportunity, I should do that. Also, you can do this too, which I'm going to do for most of our problems today. This process, guys, quiet please. It's called busting the fractions, and it's kind of a funny term. Yeah. So anyway, busting the fractions. How do I do that? What you do is you find the LCD for everything. LCD. No, that's just what I call it. So what's the LCD for everything here? Everything. 4x, right? So this is what you do. 5 over x minus 7 over 4 equals 9 over x. You multiply everything by 4x. If you do that, here's what happens. These x's go away, so you get 20. These 4's go away, you get negative 7x. And these x's go away, you get 36. Instantly, the fractions are busted, and you move forward the problem. And trust me, when we get to the more advanced problems today, this will be your savior. If you can't combine fractions, actually that would be better. But that's not what's going to happen. Then combine them totally, but that's not what's going to happen though. You'll see. Yeah, Patrick, go ahead. Of course, right. Your LCD changes as a result. Okay, so let's try the next one, guys, and then we're going to do more advanced ones down the road. So this one right here, guys, quiet please. Thank you. The LCD here is 7x. So what I'm going to do is You can combine the two if you want. But I'm gonna just do this. I'm gonna multiply everything by 7x. So what happens, you only multiply the numerator by 7x, but as a result, you're gonna cross cancel with the denominators.
Wait, what?
I know, well, trust me. Just trust me. Just trust me.
Oh, I did something.
So you get 3x plus 56 equals 7x. 4x equals 56. X should be 14.
Why don't you just get rid of
You can
the?
just move the one to the other side.
So what I did was, each of these terms here, I multiplied by 7x. So I multiplied 3 over 7 by 7x, and x by 7x, and 1 by 7x.
Then how does it just go away?
Because 7x times fraction, these terms will cancel. Because 7x is a fraction, right? But what's below it?
One.
So you multiply two fractions, you can cross cancel if they have same factors, right? Which you do.
I see it.
No, and I agree with you, Alex. Yes, you could just combine those two fractions and work it out. But trust me, when it's more advanced ones, this is me a better way.
Just trust me on this.
If the if 7x on the other side, is that if the one canceled out, the one on the
Oh,
bottom?
wait, why put 7? Yes, exactly. Yes. Right.
The one. There?
Yeah, you're asking why the LCD is 7x, right?
No.
Oh, what are you asking?
How you got 7x when you said one times 7?
No, the LCD is 7x for the left side. That's all.
1 times 7x is.
Right. Okay. I'm gonna jump. Okay, guys, quiet, please. I'm gonna jump to number 9 because I think you guys need some convincing as to why my way is the best way. Here we go, guys. How do you factor x squared minus 9?
X minus 6, x plus 8.
X minus. Good. Okay. Oh, go ahead, AJ.
Just use x. 3x.
3x. What do you mean by 3x? Well, okay.
The next page.
Well, look, here's my notes.
Wrong notes.
No, it's they're labeled. No, that's my fault. They're labeled a little differently. It's 8.5 part 2. Yeah, you were doing totally wrong material. Yeah, but the numbers are totally different though. I don't know. Okay, whatever. Let's move on, guys. All right. Anyway, okay. Hopefully, okay, we're on the right page, guys. Example 9, page 8. Yeah. Okay. So, really quickly, the denominator for the first fraction x minus 3. On the far right is x plus 3. X minus 9 already has those two built into it. So the LCD for everything is that. Here's how I'm going to work it out. Let me rewrite the problem. 6 over x minus 3 equals, I'm going to leave some space here, 8x squared. And I'm going to write this as x plus 3, x minus 3. Leave a little space. Negative 4x over x plus 3. And what you're going to do is multiply every single fraction by the LCD. It's not that hard, guys. It's not that hard. This is actually going to be the best way to do it. Trust me.
It's just hard for me because I never really learned like fractions. Because I don't really.
Well, totally. I get it. Yeah, absolutely.
It's like in 3rd grade, I just did not do math.
I'm sorry.
Oh no, it's
How'd that happen?
one of the teachers left me at 1:30.
Okay. That sucks. That sucks. All right. Anyway, x minus 3, guys. What? First fraction here. What happens to x minus 3's? Gone. Second fraction. Yes, good. Thank you, Jamie. Next one.
Both of them are gone.
Gone.
Both of them are gone.
And the last fraction.
Just the x was.
So what are you stuck with now? You're stuck with 6 times x plus 3 on the left side. Where you're stuck on the right side, just 8x squared, 4x. You've now made this problem way simpler by eliminating the fractions right from the first step.
Wow.
At this point, I trust you guys could solve it because you guys did this stuff first semester, but we'll do it anyway. Does that make sense what I just did? Again, you're not multiplying top and bottom. You're not combining fractions. What you're doing is you're eliminating fractions, busting them by multiplying the tops by the LCD of everything from both sides, and then things cancel. So in this case, you get 6x plus 18, right? You get 8x squared. You get negative 4x squared and positive 12x. At this point, you should be able to factor it pretty nicely. Should be 4x squared plus 6x plus 18. Yep. Minus 18. Thank you. Right. Right. So let me do it up here in blue. Yeah, what Hugo said, factor out the 2. And then you can do the little diamond thing if you want. Some people like to do that little diamond thing when they factor. Negative 18 and 3. Negative 6. The 6 and negative 3. Yeah, so then that should come out to
4x minus 6 times x.
let's see. So you get 2x squared plus 6x minus 3x minus 9. You can do factor by grouping. You do factor by grouping. You get 2.
What?
Why would you
That's
think?
right.
2x. Hold on. Let me back up, guys. Let me back up. Let me back up. Let me back up. Let's back up. All right. No, true. I'm just gonna put the factor form right away. Yeah, that's fine. That's fine. You guys get that? As your factor form?
Oh, I was just
Yeah, good. So the x is 3/2. If you need help with factoring, I'll help you guys offline with that. Well, bless you. So you get 3/2 and negative 3. However, one of them's not okay. Negative 3 is not okay. So the answer is 3/2. Yeah. Yeah, go ahead. Sure. Here, let me pause the video. Yeah, we are.
Oh, there's like 3 more pages.
Yeah, I'm gonna skip some pages.
Are we gonna do the class?
No, that's just a review. Yeah. All right. So again, we're skipping example 8 because repeat of example 6. All right.
Wait, where's? It's the next page.
Next page. Okay.
This page.
Okay, guys, let's go to example 10. Actually, hold on a sec. Hold on a sec. Give me a sec here, guys. Okay, so officially I'm done covering new content because that was actually the last topic of how to solve an equation like that. 8 so we did do 8.6. They're mislabeled in the notes. So what 8.5 part 2 and 8.5 part 3 is actually 8.6. They're totally mislabeled in the notes. Stuff you're doing is actually, the stuff you're doing actually goes back to 8.4. Believe it or not. So I know. Yeah, it's no, but so you 8.6 here. Yeah, we're not. Let's do another prox problem, guys. Hold on. Let's do another prox problem. Yeah, totally. Yeah. Okay, so guys, let's go to the last page of the notes, guys. Quiet down, please. Thank you. Thanks. All right. So let's do 7 and 8 on the last page. This way, I make sure that you guys can do this new topic we just talked about. So here's what we're gonna do. for example 7, sorry, for number 7 of page 15, I would probably bring this fraction over here. Get 1 over x. Last page.
We just, I think we went to. This matter. The last time we did it, they didn't want us to submit it.
Oh, I see it.
Cause I was gonna say last time, I like didn't.
Last page, guys, last page. Okay. So for number 7, guys, quiet, please, thanks. When you see 2 fractions in the same denominator, combine them, right? So that's probably gonna be the easiest way to do it for something like number 7. However, for number 8, here's what I want you guys to do. Yes, bless you.
Actually, no, you should just move 2x.
So the LCD is this. So what you're gonna do is bust the fractions. I know, it's funny. What that means is you're gonna multiply top by the LCD.
But you went to what?
So you're gonna do this, guys.
But I didn't see this.
We are doing 7. I'm setting it up for you guys. You guys are doing. I know, I'm talking a lot. I'm doing a lot of stuff. So I want you guys doing 7 and 8 on the last page. And then we're gonna start the homework. Okay? Here we go. Okay, I teed it up for you guys. Workout 7, workout 8, and let's see what we get. There we go. I'll pause the video. All right, here we go, guys. Here's my solutions. Okay, so really quickly, the x plus 1 over x plus 6, I bring it up to the other side. And notice I put parentheses around x plus 1, so I distribute correctly. But I distribute correctly, I get x as the numerator on the right side. Cross multiply. Factor correctly, you get 3, -2, both will be fine.
So me and Jeannie both got -3 and +2.
So you probably have a negative somewhere mixed up. I'll need to double check your work. And then lastly here, when I bust the fractions, the x and x minus 3s cancel for the 18. The x minus 3s cancel the second fraction. The x's cancel the last fraction. The second step looks really clean. It's a linear equation, solve it. You get 3.
There's no solution.
But the problem is that you can't plug in 3 into the original equation, right? Because it'd be divided by 0. So hence there's no solution. And that's it. That's how you do it. Now, one thing I do want to teach you guys, if you have your graphing calculator, please follow along. If not, I'm recording this so you can watch later. But you can check your work, because I'm going to probably put this in a calculator portion of the test next week. And sometimes you're wondering, like, there's so many steps. Did I do this right? I'm not sure. I mean, of course, you can always throw it back in the original equation, see if the left side equals the right side. The way you can give yourself more validation that you got this, here's what I do. So I'm going to go to my graphing calculator app. I could go Desmos, but you don't have Desmos on test, unfortunately.
Wait,
so
would we get graphing calculators for these problems?
yeah, I'm fine with that. I don't care. That's fine. But you still show the work, so it doesn't matter to me. Here we go.
Would we not get graphing calculators for the graphing bit?
Of course not. No. All right. So here we go, guys. Let me show you how you want to check your work. So for number 8, if you go to y equals, guys, quiet please. You do 18 divided by parentheses x squared minus 3x, right? And then subtract that with 6 divided by parentheses. Remember, you got to be very OCD with your parentheses, guys. Otherwise, it's going to not know what you want. The calculator is going to be confused. And then 5 over x. And then when I graph it, I usually like to go to Zoom and option 6. It's a nice window. So here's the first graph. It's a rational function, right? Second graph is coming. Do those graphs touch?
No.
Hence,
No
solution, right? That's how you get validation that you've done this correctly. Let's do it for number 7. For number 7, I'm going to do parentheses x plus 1 divided by parentheses x plus 6. And then plus in parentheses 1 over x. Again, be very OCD with your parentheses, please. And by the way, if I don't put parentheses, just so you know what goes wrong, because I know you guys are just learning the calculator, right? But what's the calculator going to think when it sees this? The second equation. I did it wrong, by the way. The second one I did wrong.
What's the calculator gonna think is these 2x plus 2x plus 1 over x plus 6, right? What's the calculator following? What rule that we talked about? It's gonna do the 1 over x first. It's gonna get so confused.
So what you need to do is insert a parentheses. If you hit second, you can clear and do it over again, or you can just insert. Not hard. Oh, yikes. Okay. Let me just type in parentheses x plus 6. All right. Graph in the standard window. See what happens. Here we go. Here's the first one. It's a rational function. It's kind of funky. Second one's coming. Boom. Another 2 points of intersection. 2 points of intersection. You can find those. Second trace intersect. If you move close to it, hit enter 3 times. 1, 2, 3. There you go. -2 is one of them. Do it again. Option 5, intersect. So you have to second trace to call up that window. Gosh darn it, what'd I do? Here we go. Hit enter 3 times. And the other one's 3. So,
Oh, that's pretty neat.
yeah. So you guys can check your work. So if you ever are not sure, this gives you the validation. So you walk out of test feeling confident with your answers, right? So, all right, anyway, I'm all done. So I did say about 30 minutes. I was man of my word. So at this point, let's just work on the homework just to get it done. So we have a half hour in case you want to watch the Warriors-Lakers game. I think Warriors are going to lose tonight, but we'll see. So you guys doing 1 through 19 odd, okay? 1 through 19 odd of 8.6 homework, okay? It's right at the end of the homework packet, and the answer key is provided. Odd, so 10 problems. So you're doing 10 problems, 1 through 19 odd. So you're starting here, guys, all right? And let's get to work, all right?